Feature engineering is a process that manipulates your data, adding new features, removing highly correlated features, and combining features to create new features, all with the goal of improving training and your model's prediction capabilities. Feature engineering is an art that requires you fully understand your data and the relationships between features. When reviewing the data, there are 207 rows where the total bedrooms are missing. We know this to be an error because all homes have at least one bedroom, right? These missing values could skew the model, so we'll need to deal with them appropriately. There are several ways to handle missing data. Delete rows with missing values, use machine learning to predict missing values, replace missing values with the mean or the average score, or use machine learning algorithms that handle missing data gracefully. We want to feed the model data that is most relevant to predicting the median home value target variable with no overlapping features. You learned that features with very high correlation teach a model similar things, so they are candidates for removing and even combining. We've identified a strong correlation between total bedrooms to total rooms, population to households, and households to total rooms. The strategy is to create a relatively simple combination of the correlated features and drop the rest. We'll also create a new feature combining longitude and latitude, as there is a negative correlation. Here on this first line, a new feature, which is a ratio of the total rooms to households, is created, and we call it rooms per household. Next, a new feature, which is a ratio of the total bedrooms to the total rooms, is created, and we call it bedrooms per room. Next, a new feature, which is a ratio of the population to the households, is created, called population per household. And lastly, a new feature that is a combination of the latitude and longitude into one new feature is created. I'm calling it coordinates. After creating the new features, we'll remove the original correlated features: total rooms, households, total bedrooms, population, longitude, and latitude. Next, we'll display the new heat map, which shows that the high correlation no longer exists. Most machine learning algorithms can only learn from numeric data, so categorical data, or data represented in string format, must be encoded or converted to numeric data. The only string value we have in our dataset is ocean proximity. We'll use an encoding technique called one-hot encoding to convert the ocean proximity categorical data to numerical data. One-hot encoding creates new binary columns, indicating the presence of each possible value from the original data. There are currently 5 possible values for ocean proximity: less than 1 hour away from the ocean, inland, island, near the bay, or near the ocean. We'll have a new column for each possible value, and then a value of 1 in that column if that's the value, or a 0 if it's not. Once we've encoded ocean proximity, we can remove the original columns. One-hot encoding can cause high cardinality, which means as the number of features or columns increases, you can experience the curse of dimensionality. We added 5 new features to our dataset and removed 1. It's important to remember that as features increase, it makes it harder for the model to learn and generalize, and can increase your training costs. Now that you're familiar with feature engineering, let's see it in action.